Okay, today we are going to talk about relative motion of particles. When we say relative motion, what do we mean? Think about you have a particle moving on a path, let's say a path like this, and you have at any instant you have this particle A. Okay, so we can define the motion of A with respect to a coordinate system which is fixed to the ground. Let's say this coordinate system to be x and y. And let's say we have another coordinate system, another observer, but this time this observer is moving. Okay, so let's say you have another observer, x prime, y prime. Let's say we can put x prime, y prime, and this coordinate system is located based on the fixed coordinate system. Let's say currently it is located at B. Now, if we define the position vector of A with respect to fixed coordinate system, we can just say RA, as you can see here. And also, we can define the position vector of the moving translating coordinate system, which is B, RB. And now we can define the movement of A with respect to translating axis, which we can draw the position of A with respect to this translating system, and therefore we call this RA with respect to B. So if you write what is what, this is the fixed coordinate system, this is fixed coordinate system, and this is the moving or translating coordinate system. And based on this, what we can write, based on this triangle as a vector, we can simply write RA, the position of A can be written as RB plus RA with respect to B. So this is a vectorial relationship between the position of A with respect to fixed axis, position of the B, which is the origin of the translating axis, and the position of A with respect to B, which is with respect to the moving axis. So this relation is relative position equation. So by taking derivative of this expression, we can write the same thing about velocities and accelerations. So we can simply say VA equals VB plus VA with respect to B, and AA equals AB plus AA with respect to B. So these are the kinematic relations for relative motion, which is very important. Okay, so how can we make this more concrete situation? Think about you are moving on a plane. Let's say, how can we explain this? We can explain this like this. You are someone on the ground here, and there is a plane. Okay, there is a plane moving, which has also a propeller, let's say. Okay, and you want to observe. Let's erase this part of the plane, so it is more likely to be a plane, and this was actually the place where the pilot sits. So let me draw that better. And let's say there's a pilot in it, okay, which is driving the plane. So the motion of this tip of the propeller, differs based on the observer, which the pilot can be represented as B, and the fixed observer can be represented as A, and the point of interest here, which actually, let's say the point of interest is simply the motion of the propeller A here. So what we can write based on this observer, we can write the position of B, which is the pilot, and we can write the position of the propeller A here, and we can simply write the position of the propeller, tip of the propeller, with respect to the pilot. So if this is B, the position of pilot B, if this is the position of the propeller, tip of the propeller, and this is going to be our A with respect to B. So, for example, as an observer from the ground here, we know that the position of the B is just simply a translation. So you can see it like the plane is moving, simply a translation. And based on the observer at B, which is the pilot, the propeller just does a rotational motion. And as someone on the ground, what you're going to see, both translation and rotation. So it's a very beneficial relation using the translational axis, using the relative motion. We can analyze the motions easier. Okay, let's solve an example about relative motion. So this is a typical example. There are two cars here, one going on a straight line and one taking a round road. So car A moves, as you can see here, car A moves towards right with 50 km per hour with 3 meters per second square acceleration, which means it is accelerating. And car B takes the circular path with radius 20 meters with 70 km per hour constant velocity. Now my question is this: what is the velocity and acceleration observed by A for car B? Okay, so the question is this: what is the velocity and acceleration of B observed by car A driver? So basically, in mathematical form, what I'm asking for is what is velocity of B with respect to A, and what is acceleration of B with respect to A. So for this, we're going to utilize the relative velocity and acceleration equation. Remember, relative velocity equation, VB equals VA plus VB with respect to A. You can switch the letters here. I mean, you can write VA equal VB plus VA with respect to B, but this is also possible. And also for acceleration of B equals acceleration of A plus acceleration of B with respect to A. Based on this, in order to answer the question, VB with respect to A equals VB minus VA. And similarly, acceleration of B with respect to A is simply AB minus AA. So we need to determine these. What are these numbers here? What are these quantities here? These quantities are the velocities and accelerations observed from a fixed reference point, which is us looking from outside. So you can just put a coordinate system xy somewhere here. As you can see here, it's a fixed coordinate system. And based on this, you can write VA, VB, AA, and AB in vectorial form. Let's do that. But before doing that, let's convert the kilometer per hour to the meter per second so that we can write everything in meters and seconds. So therefore, what I want to do, I want to convert this to the 50 over 3.6 to make it meter per second, and similarly for VB, 70 divided by 3.6. So let's calculate those. So this is 13.89 meter per second, and this is 19.44 meter per second. Based on this, if I want to write as a vector, as a Cartesian vectors, let's start with VA here. VA is going to be 13.89i. Why? Because it is going towards right, so therefore it is going to be, the unit vector is going to be in I direction. And similarly for acceleration of A, let me put our xy coordinate down a little bit here. Acceleration of A is similarly 3i. So these are the vectorial quantities for VA and AA. So let's put a vector sign here. And similarly for VB, I can say 19.44. And because it is moving upward, it's going to be in y direction, so the unit vector is going to be j. When it comes to acceleration of car B, we have two accelerations because it is moving on a circular path. If it's moving on a circular path, it is going to have two accelerations, one tangential and one normal. Let's indicate those, tangential and normal acceleration. So this is T direction and this is N direction. Why? Because it does a circular motion. Because the car takes a circular road. But the tangential one is 0. Why? Because the velocity is given as 0. So therefore, for AB, tangential, it is 0. Because the velocity is constant. But when it comes to normal, we always know that if it takes a circular path, we're going to have a normal acceleration. So remember the normal acceleration formula. AB normal is going to be VB squared over rho. And because velocity of B is given as 14.99, so it's going to be 19.44 squared divided by 20, because the radius is given as 20 meter in question. So therefore, acceleration of B is going to be 19.44, and this is going to be 18.89 meter per second square. So if you look at the direction of the normal, it is going to be in negative x direction. So therefore, if I want to write AB in vectorial form, I can just say that AB is going to be negative 18.89i. So this is acceleration of B as a vector. So we determined acceleration of A and velocity of A in vectorial form, velocity of B and acceleration of B in vectorial form. Now we can plug in these to calculate whatever the desired quantities. So let's start with VB with respect to A. VB with respect to A is going to be VB, which is going to be 19.44J, 19.44J minus VA, which is going to be 13.89 I. So it's going to be 13.89 I. So if we write in order, B with respect to A is going to be minus 13.89 I plus 19.44 J. So this is the velocity observed by car A for car B. So which means an observer in car A senses the velocity of B as a negative in x direction, which is the negative of velocity of itself, and plus a positive acceleration in y direction, which is quite reasonable. And when it comes to accelerations, we can write acceleration of B with respect to A, which is AB minus AA, and AB is minus 18.89 I, and minus AA, which is 3I minus 3I, and this is going to give me acceleration of B with respect to A to be minus 21.89 I, which indicates that the acceleration of car B is sensed by car A as negative 21.89 meter per second square. So these are the answers for the question. So this is answer and this is answer.